Hello, dear students. Let us today study about the versatile nature of carbon. We are well aware that, sorry, we are well aware that carbon has a atomic number Z is equal to 6. So carbon has its atomic number Z is equal to 6. So we can write the electronic configuration of carbon 2, 4. So we can write the electronic configuration of carbon as 2, 4. That is how it goes 6. So my dear students, it's quite easy for us to understand here that we have the electronic configuration of carbon as 2, 4. So in K shell we have 2 carbon and in L shell we have 4 carbon. These 4 carbon are known as the valence. These 4 electrons are known as the valence electrons. So carbon atomic number 6, electronic configuration is 2, 4, number of valence electrons is equal to 4. So carbon has a valency is equal to 4, and that is why carbon is tetravalent in nature. Carbon can make 4 bonds at a time. Please remember, my dear students, that as the carbon has 4 electrons in its valence shell, carbon can make 4 bonds at a time. Now, this is the specialty of carbon. So we can say it is an extra edge, or it is the good characteristic of carbon. Now we want to study the next good characteristic of carbon. That is what it is known as the catenation. Carbon has unique ability to form bond with other atoms of carbon, giving rise to large molecules. This property is called catenation. Please remember that carbon has a unique ability to form bond with other atoms of carbon. That means carbon can even make bonds with carbon and make long compounds where so many carbon can be bonded to each other at the same time. This giving rise to the large molecules. That means when carbon combines with carbon, it can make large molecules. The molecules are made in such a way that they have large number of carbons. This property is called catenation. Once again, my dear students, because catenation is an important definition, let us revise. Carbon has unique ability to form bond with other atoms of carbon, giving rise to large molecules. This property is called catenation. Those compounds may have long chains of carbon, branched chains of carbon, or even carbon atoms arranged in the rings. So, my dear students, when carbon combined with other carbon atoms, it can make long chains of carbon, it can make branched chains of carbon, or even it can make the ring compounds. We have already studied about these compounds as cyclic compounds in the previous discussion. In addition, carbon compounds, carbon atoms may be linked by single, double, or triple bond. We have seen, my dear students, that carbon can make single bond, carbon can make double bond, and carbon can make triple bond. So in addition, carbon compounds, carbon atoms may be linked by single bond, may be linked by double bond, may be linked by triple bonds. Compounds of carbon which are only linked by single bonds between carbon atom are called saturated compounds. Compounds of carbon having double or triple bonds between their carbon atoms are called unsaturated compounds. No other element exhibit the property of catenation to the extent seen in the carbon compound. So my dear students, no other element exhibit the property of catenation to such an extent that carbon can have. So carbon has got the highest catenation property. My dear students, please remember that the compound of carbon which are only linked by single bonds, we call them as alkanes. So alkanes, all the alkanes have only single bonds present in them. Same way, those compounds which have either double bond or triple bond, for double bond we use the word alkene, and for triple bond we use the word alkyne. So this way, my dear students, we have these alkanes which are the saturated compounds, but alkenes and alkynes which are unsaturated compounds. Carbon has got maximum property to do the catenation, that is now we should understand. Then the third speciality of carbon that we can understand, carbon-carbon bond in carbon compound is very stable, very strong bond and very stable and very strong bond. Carbon apart from carbon make bonds with the hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, fluorine, phosphorus, sulfur, etc. So you can easily understand that apart from carbon, carbon can make bond with so many other elements. Hardly other elements can make such a huge amount of compounds. Thus we can say that bond formed between these elements and carbon is exceptionally strong and stable. Due to small size, carbon can make strong bond with carbon and carbon can make strong bond with the other elements too. Carbon can make single, double and triple bonds. It's not only that carbon can make bond with so many elements, but with these elements, carbon can make single bond, carbon can make double bond, carbon can make triple bond even. So that is why, my dear students, we can say that carbon can make a single bond with oxygen, carbon can make double bond with oxygen, carbon can make single bond with nitrogen, carbon can make double bond with nitrogen, carbon can make triple bond with nitrogen, carbon can make single bond with sulfur, carbon can make double bond with sulfur, carbon can make single bond with phosphorus. Thus, carbon give rise to huge number of compounds which are stable and huge in number. Above points explain the versatile nature of carbon. So you can see that due to this very important three characteristics of carbon, we can say that carbon is versatile and it has got a specific nature to form compounds. So this is how we studied about the versatile nature of carbon. Now, my dear students, we want to study about the allotropy. So let us study about the allotropy. The phenomena of having more than one form in the same physical state by an element is called allotropy. The phenomena of having more than one form in the same physical state is called allotropy. The various forms of element in the same physical state are called allotrops. You know, my dear students, generally various elements do not have more than one forms in their same physical state, but some elements have more than one form. We will study about them. So this having more than one form in the same physical state is known as allotropy, and these various forms of the element which are there in the same physical state, they are known as the allotrops. Various elements such as carbon, sulfur, phosphorus, etc. show allotropy. Please remember that various elements such as carbon, sulfur, phosphorus show allotropy. So suppose you are asked which elements show allotropy, you can easily answer that carbon, sulfur and phosphorus are the elements that shows the allotropy. Allotropes of carbon are diamond, graphite, and fullerenes. So diamond, graphites, and fullerenes are the allotropes of carbon. Let us study each allotrope one by one. So now we are going to study these allotrops one by one. Let us please pay attention to the allotrops of carbon. Let's look at diamond. In diamond, each carbon is bonded to four other carbon. You can see that if you look at this carbon, you will realize that it is bonded to 1, 2, 3 and 4 other carbons. See, 1, this is 2, this is 3 and this is 4. So here I have shown you the structure of a diamond in which all the carbons are bonded to the four other carbons. So in diamond, each carbon is bonded to four other carbon. All the valencies of carbon are satisfied well. Thus, diamond make rigid three-dimensional structures. Now, why is it three-dimensional? So if you really look at this, you can see that some of the bonds are coming towards you, whereas some of the bonds are going away from you. So if you look at this, the bond between, like this bond, you can see this bond, if you really look at this, you will realize that this carbon is bonded to this carbon. These two bonds are coming towards you, whereas this bond is going at the back side of the screen. So this is how we can understand that this is a three-dimensional structure and it is a huge molecule of diamond. Thus diamond makes a rigid three-dimensional structure and make a giant molecule. You can see there are so many carbons present in it, and it is a single molecule of carbon because all the atoms are of carbon itself. So diamond is a giant molecule of carbon. Diamond is a three-dimensional structure. Diamond is a rigid structure. Diamond is poor conductor of electricity. These are the properties of diamond. And diamond is used to make jewelry. Diamond is the hardest substance in the world. So these are the three properties of diamond that we can study. The diamond is a poor conductor of electricity. Diamond is used for making jewelries, and diamond is the hardest substance in the world. Now, my dear students, we want to study about the second allotrop of carbon, which is known as the graphite. In graphite, each carbon atom is bonded to three other carbon atoms. In graphite, each carbon atom is bonded to three other carbon atoms in the same plane, giving a hexagonal array. You can see that each carbon is bonded to three other carbon. You can look at this carbon. This carbon is bonded to three other carbon, 1, 2, and 3. So same way, you can think it for all the carbons, that you can see that all the carbons have bonded to three other carbons. You can even think of this, which is bonded to 1, 2, and 3 simultaneously. So in graphite, you can say that each carbon is bonded to three other carbons. At the same time, it gives the hexagonal structure. Thus, only three valencies of carbon are satisfied. Fourth valency is satisfied either by making double bond or by keeping the third electron of each carbon free between the two layers of hexagonal arrangement. So the fourth bond is the fourth electron. The fourth bond that is possible in carbon, because carbon has got four valence electron. The electronic configuration of carbon is 2,4. So carbon has four, carbon Z is equal to 6. So carbon has four valence electron and it can make four bonds simultaneously. But here it makes three bonds. So one electron is left. This one electron remains either free between these two layers, or it is used to make the double bond, or my dear students, double bonds are formed. So either the double bonds are formed between this carbon somewhere, or this electron remains free in the structure. So this is how we study about the structure of our graphite. We can easily realize now here that one electron is either free or it is doubly bonded into the structure of graphite. The hexagonal layers of carbon are arranged one above the others. Now you can see that, my dear students, very easily that this is layer 1, this is layer 2, and both these layers, layer 1 and layer 2, are arranged one above the others. So the hexagonal layers of carbon are arranged one above the others. When force is applied, the layers of graphite slip or move over each other. Thus, graphite is smooth and slippery. Now, please understand here that these layers, when the force is applied from any side, these layers of graphite slip over each other, they move over each other, and that is why graphite is smooth and slippery, because the layers can move over each other. That gives graphite a smooth and slippery structure. Graphite has fairly high melting point. Please remember that the melting point of graphite is quite high. Thus, graphite is used as a lubricant even at high temperatures. So as graphite is smooth, as graphite is slippery, as the layers of graphite moves over each other or slip over each other, what happens? Graphite can be used as a lubricant. So graphite can be used as a lubricant, and it has got fairly high melting point, and that is why graphite is used as a lubricant even at high temperatures. So those lubricants like oils and grease which do not work at high temperature, graphite can work at high temperature as a lubricant, and that is why graphite is used as a lubricant even at high temperatures. Graphite conduct electricity. Now please understand this, that graphite can conduct electricity. Why does it conduct electricity? We have seen that graphite has carbons, and carbon has Z is equal to 6. So its electronic configuration is 2, 4. Graphite makes only 1, 2 and 3 bonds simultaneously. So one electron remains either free, or this one electron is used to make the double bonds. This electron actually makes the graphite to conduct electricity. And graphite conduct electricity. Why does graphite conduct electricity? Graphite conduct electricity because that is what it is written. Graphite conduct electricity due to the free electron. Graphite conduct electricity due to the free electron, or the fourth valency of carbon has not been satisfied into the graphite. Once again, let us read it. Graphite conduct electricity due to free electron of fourth valency. Graphite is used as an electrode. So as graphite can conduct electricity, we can easily understand that graphite can be used as an electrode. Graphite is used in the pencil as well. As on applying force, its layers slip over each other or slip over each other. So my dear students, graphite is very smooth and slippery. So graphite is used as an electrode as it conducts electricity. At the same time, graphite is used in pencil. Graphite is also used in pencil because when the force is applied, the layers of graphite slip over each other or move over each other, and that is why the layers of pencil that comes on the paper and we can write. And that is why please remember that as on applying force, the layers of graphite slip over each other, the graphite is used into pencil. So these are the various characteristics and structures of graphite. Now, my dear students, we want to study about the another allotrop of carbon, which is known as full ring. So now let us study about the full rings. Full rings are the other class of allotrops of carbon. So we have studied about the three allotrops of carbon. Now, which are the three allotrops of carbon? The three allotropes of carbon are generally diamond, graphite, and fullerenes. The three allotropes of carbon, the three allotropes of carbon are diamond, graphite, and fullerenes. Now let us pay attention to the fullerenes. So fullerenes are the other class of allotropes of carbon. The first fullerene which was identified was C16. That means there were 60 carbon present into the structure or smallest structure of fullerene, in which carbon atoms are arranged in the shape of the football or soccer ball. Please remember that in fullerenes, the carbon atoms were found arranged into the shape of the football or a soccer ball. Since these looked like the geodesic dome designed by US architect, since it looks like the geodesic dome designed by the US architect Buckminster Fuller, the molecule was named fullerene. Please remember, my dear students, that it was looking like a geodesic dome designed by the US architect. His name was Buckminster Fuller, and that is why the name fullerene is given to it. Please remember, if you are asked the questions that why this why the name fullerene is given to the another allotrop. So the name fullerene is given to the allotrop because the structure of fullerene was very similar to the geodesic dome, designed by US architect. The name of this architect was Buckminster Fuller, and that is why on the surname of this architect, this allotrope of carbon is called fullerene, and this is how the name fullerene is given to the third allotrope of carbon. Now, my dear students, let us study some of the other questions based on the allotropes of carbon. Next question: how can we synthesize diamond? Explain. So diamond is synthesized by subjecting pure carbon to very high pressure and temperature. Diamond is synthesized by subjecting pure carbon to very high pressure and temperature. It simply means that we can prepare diamond by giving a huge amount of pressure and a very high temperature to the pure carbon. So when we apply huge amount of pressure and a huge pressure to the pure carbon, diamond can be formed. Note an important thing about diamond: synthetic diamonds are small but indistinguishable from the natural diamond. So if we prepare diamond by ourselves by applying huge amount of pressure and temperature on pure carbon, we get diamonds. The diamonds which we prepare is known as the synthetic diamond, and these synthetic diamonds are small in size, but they are indistinguishable, means they look exactly like the natural diamonds. That is what it means. So now we understand that we can even prepare diamonds, and the diamond that we prepare is called the synthetic diamond, and synthetic diamond is same as the natural diamond look wise. Now we have one reason: diamond is the hardest substance on the world. What is the reason that we consider diamond as the hardest substance on the earth? Let us study the reason why diamond is the hardest substance on the earth. Diamond is the hardest substance on the earth. In diamond, each carbon is bonded to four other carbons strongly and make three-dimensional network solid and a giant molecule which is most difficult to be broken. Thus, diamond is the hardest substance. Due to the same reason, only diamond can polish diamond, and diamond is used as an abrasive, or it is used in the cutting tools or to cut the glass. So let us this is how we have read the text. Now let us understand. Diamond is the hardest substance. It means that there must be a structure which is hard. So in diamond, each carbon is bonded to four other carbon strongly, and it makes the three-dimensional network solid. and a giant molecule which is most difficult to be broken. Now this is the very important thing, that it is difficult to break the diamond, and thus diamond is the hardest substance. So why diamond is hardest substance? Because in diamond each carbon is bonded to four other carbons. First thing, the bond formed between carbon in diamond are very strong. The diamond make a giant molecules. It is a three-dimensional molecule, or it is a three-dimensional network solid, and thus it is difficult to break the bonds into the diamonds, and that is why diamonds is the hardest substance in the earth or in the world. Now, due to the same reason, means as the diamond is the hardest substance, only diamond can polish diamond. Please remember that only diamond can polish diamond. But as it is the hardest substance, it can cut other substance. So diamond is used as an abrasive. What is abrasive? Abrasive is nothing but the substance or the tool that is used to cut other substance. So diamond is used in cutting tools. Diamond is also used to cut glasses. So whenever you want to cut glass, it is preferable that we use diamond, because diamond sharply cut glass nicely. So these are the reason why we consider, or why we use diamond in the cutting tools or as an abrasive. Let us study a few more reason why diamond is used in the jewelry. Now this is the question, my dear students, that we can easily we know that diamond is used in the jewelry. So what is the reason why diamond is used in a jewelry? Diamond has very high refractive index. Diamond is polished before using it for jewelry. First thing that you might have studied in physics even, that diamond has got very high refractive index. Please remember that diamond has got very high refractive index. Second, diamond is polished before using it. So before we use it into the jewelry, diamond is polished. It is polished in such a way that light falls on diamond, fills multiple total internal reflections. Now, this is what it is important to understand, that when light goes into the diamond, it undergoes the reflection more than one time. So, multiple time. Many a time the light reflects. This multiple reflection, this way on falling light, diamond shines. So due to the multiple reflection of light, diamond starts shining, and that is why it is used in the jewelry, because shining diamond looks very nice, and that is why diamond is used into the jewelry. Now, my dear students, we have the next reason to understand that why graphite is used in the pencil. We have seen that we use graphite into the pencil. What is the reason? Well, I have already explained, but let me explain it once again. Graphite has layers of carbon atoms arranged hexagonally. When force is applied to graphite present in the pencil, layers of graphite slips and come out on the page so we can write. Thus, graphite is used in the pencil. Please remember, my dear students, that graphite has hexagonal layers arranged one over another. When we apply force, they slip over each other, or they slip over one another. They move and they come on the pages. So as they come on the pages, we can write, and that is why graphite is used in the pencil. Now, graphite conduct electricity. Why graphite is conduct electricity? That is the reason we want to study. So our next question is, why graphite conduct electricity? The answer is simple. Let us see what is the reason. Graphite conduct electricity because only three valencies of carbon is satisfied in the graphite. Fourth valence electron is free or in the double bond, which helps to conduct the electricity, and graphite is used as an electrode in the cell. So we have seen it, that graphite, we have just revising it once again, that graphite can conduct electricity, as well as graphite is used in the as an electrode into the cells. Graphite is soft, its layers sleeps over each other, and graphite has high melting point. So graphite is used as a lubricant even at high temperatures. We have seen, let's revise it, that graphite has got a fairly high melting point and graphite is soft. So graphite is used as a lubricant As it is soft, it can be used as a lubricant, but it has got high melting point. That is why graphite can be used as a lubricant even at higher temperatures. My dear students, we have studied about the saturated and unsaturated compounds already, but let me remind you once again that saturated compounds are generally, in hydrocarbon we have alkanes, which are saturated compounds, whereas unsaturated compounds are there, which we call them as alkenes or alkynes. Now let us study the difference between the saturated and unsaturated compounds. Let's study some four various difference between the saturated and unsaturated compound, and we'll finish the class. So first difference, compounds of carbon, those have all the bonds single. Please remember, all the bonds singles are known as, and no double or triple bond present are called saturated compounds. Whereas compounds, these have at least one. Remember, these compounds, saturated compounds, must have at least one double or triple bond present. They are known as the unsaturated compounds. Second, saturated compounds are good fuels. They produce more energy as compared to the unsaturated compounds. Unsaturated compounds are not so good fuels. Compared to saturated compounds, they produce less energy. So second point is about the energies, and saturated compounds are good fuels. Unsaturated compounds are not good fuels. Saturated compounds produce more energy when they are burned. Unsaturated compounds produce less energy when they are burned. Saturated compounds burns with blue flame, unsaturated compounds burns with yellow flame. Please remember the color of the flame, how they burn. So saturated compounds burns with the blue flame. Please remember, and unsaturated compounds burns with the yellow flame. Second, when saturated compound burns, no soot is produced. Please remember that when saturated compound burns, no soot is produced. When unsaturated compounds burns, the soot is produced. This soot we generally considered as a smoke which has carbon particle which is black in color, and we are not comfortable breathing in such soots. So soot is not produced in case of the saturated compound, and that is why they produce more energy. But when unsaturated compound burns, they produce soot, and that is why they produce less energy. So this is how, my dear students, we study. Let's move to the next difference. Gas or kerosene stove, if it contains the saturated compound as a fuel, bottom of the cooker or bottom of the vessel in which we are cooking does not get blackened. So if we are using the saturated compound as a fuel into the stove, which may be a gas or kerosene, in that case, my dear students, the bottom of the vessel in which we are cooking or bottom of the cooker does not get blackened if we are using the saturated compound as a fuel. But when we use the unsaturated compound as a fuel into the gas stove or into the kerosene stove, it contains unsaturated compound or unsaturated fuel, then the bottom of the cooker or vessel is blackened. It is blackened because it produces the soot, and this soot blackens the bottom of the vessel. Next one, we are going to study the examples. Alkanes like methane, ethane, butane, they are all called the saturated compounds. And the examples of unsaturated compounds are alkenes and alkynes like ethene, propene, ethine, propine, etc. So this is how, my dear students, we study about the various types of or various differences between the saturated compound and unsaturated compounds. I hope, my dear students, you have enjoyed the classes. Uh, Let us revise what we have studied today.